Let's take a few minutes and just spend some time going through some basic project scheduling tips. So this isn't going to be a lesson on how to do project management. You'll be taking courses on project management before too long. But to knock off any kind of project in any kind of a class or in any kind of early job that you get, you're going to need to know some basics of project management and project scheduling as you go through. So let's frame this discussion real quickly in terms of just some guiding questions. So, how do you develop a work breakdown structure from your project lifecycle? How are we going to make that work? And what's the best level of detail to work with for developing our basic work plans? And how do we include milestones for our reporting and at the same time build in compliance around some of the CMMI models we've been looking at as we go through? So, generally, how am I going to make that work? So, here's a central hierarchy of the kinds of things you should be thinking about as you're developing your work breakdown structures on your projects and assigning resources. And I'm not going to be able to give you tips for all of them here in this lesson, but let's talk about the whole thing. So at the top, you've got your portfolio, your program, and your project. And if you go out to the Project Management Institute, you can read about their OPM 3 model, their Organization Project Management Maturity Model, where they'll help you understand how the individual projects you work on typically exist within a program, which is broader and over time, which is part of the organization's portfolio as they see their way through. So portfolios, programs, and projects are the ways we organize work. And you could be a portfolio manager dealing with the entire brand, the program manager dealing with an overall program, or in the case of this discussion, a project manager just trying to work out an individual project. So we're going to deal with it here at the project level. I'll leave programs and portfolios for another time. Within the project, you've got to answer some basic questions. Why, what, how, who, and ultimately when is everything going to happen? So if you're looking at your engineering life cycle, chances are it gives you the why. The different phases are the why. How do we go through the engineering story from conceptualization to preliminary design to our architectures? That's why we're doing the things we're doing. So we start planning our projects around the life cycle phase that we will be in. And within that, we can plan what people are going to do, the actual tasks that they're going to make their way through as they go through. And within that, the kinds of activities that take place within the task. Some tasks take a long time to accomplish and require many activities. Some tasks are very, very short and narrow and can almost be seen as an activity. But when you're doing your planning, you want to make sure that how the work gets done gets broken out at an activity level where none of the activities are very large. The benefit of a good work breakdown structure on a project is that you'll know how things are doing. So if the typical activity has to be done within 1 or 2 days, maybe 3 or 4 at most, then on a weekly basis, you're going to have pretty good visibility into whether the project's making progress or not. If you define your task too big, maybe up to 10 days, 15 days, 20 days, then it could be a month before you know if you're on or behind schedule, and by then it's very difficult to react to that as we go through. So we're going to try to plan our activities such that the individual activities on the project never get much larger than a few days. And then within the activity, you assign your resources, your people, to do the task. I'm not going to get into that here because that's done very different in every organization. But activities ultimately get assigned to people. Again, if you've got a lot of discrete activities, you're going to find one person does each. If you've got a set of slightly larger activities or broader activities, you might find you have to assign multiple people to each. My goal is always to try to get every activity down to a low enough level of detail that it will get done quickly by one person. So if it's not done when it's supposed to be done, I know who to go talk to. Remember, your project work breakdown structure isn't just about planning, it's about control. So it has to be at enough detail to be able to control the work as it's seeing its way through. If I apply the CMMI model to that, you should be looking at the project planning process area in the CMMI, which deals with the skills and techniques you would have to establish your basic estimates for your project, develop the project plan to make that work, and attain management's commitment to that plan. After that, you're dealing with project monitoring and control. So how do you monitor work against the plans, and how do you make corrective actions to bring things to closure? So if you're only going to pay attention to one or the other, pay attention to project monitoring and control, because that's your lifeblood as you're working the project. You plan the project once, you update the plan periodically, but you spend most of your time controlling and monitoring the project against the plan as you go through. So that first step that I said is really to do phase level approaches. So here's a quick phase oriented approach, in this case, a very simple IT life cycle of 5 phases: initiation, analysis, bid and contract, design and build, and accept and implement. You'll deal with lots of different kinds of life cycles in your engineering life, so get used to those and what the phases of those life cycles would be, whether it's conceptualization, preliminary design, to detailed design, to implementation and build. But there will be phases associated with any life cycle you have to use. This example just happens to be a Six Sigma life cycle. When you're planning, try to emphasize how long things will take in terms of their duration and what the dependencies would be between them. Try to never in your plan specify a start date or a finish date. Those are constraints. The only time I enter start date or finish date is if it's an absolutely real constraint for the project and it has to happen on those days, maybe because of a contractual obligation or something of that nature. But if it's not a contractual obligation, let the plan tell you when something will be done and when the next activity will start. Only talk in terms of the duration and dependencies of the task as you go through. So here in this picture we see the 5 phases are sequentially dependent. You can see that in the predecessor column. So these phases take a total of 58 days, and each phase starts when the prior one is finished. So always start your project with a phase level estimate. Because if you can't plan your project at least a phase level and make the phase level project plan looks like it'll work, then don't bother planning the details, because you're not going to be able to get that to work either. So by doing a top-down plan, you get a phase level plan that works. Now that requires you to think in terms of how much are you going to allow the phases to overlap. It might not be realistic to say no phase should ever overlap, because usually if I'm almost finished conceptualization, at least parts of the team can be moving ahead and working on preliminary design. So it's rare you would have a project where the phases don't overlap. I usually make my default about a 1/3 overlap, the second example here. Allow your phases to overlap about 1/3, and you'll probably make realistic use of the resources on your team. At that point, then you have the option to create more overlap to try to get the project done faster. So increasing the overlap gets the project done faster, but you've got to add more resources because you have more activities going on at any one time. Less overlap takes longer, but can be done by fewer resources as they move from task to task. That's what you're trying to balance as you go through. So if you don't have a reason to do otherwise, I recommend doing your initial planning, presuming about a 1/3 overlap. You could do it for a 0, but we'll see when we get to some of the details. That's not usually realistic as we go through. So I usually use a 1/3 default, and I only go with more overlap if I really have to squeeze some time out of my schedule. The other thing you have to deal with is what's the general proportion of your phases. Not all phases take the same amount of time. For this particular engineering life cycle, in this example, I might favor the second one. 5% upfront, 25% in requirements, 10 in preliminary design, and 10 during the build. But every project is different. So you've got to decide. The least likely is probably the top one here of 20% in each of the 5 phases. But you've got to decide. This third example is a project that can get done in about half the time, but maybe has to roll out and implement in several sites. So the actual final phase will take a long time. This last example is one where most of the time is spent up here in requirements, and once we get those right, the implementation will go fairly quickly. So a balanced project is typically more like this second example. You might want to invent other examples for your environment, but the phase proportion is an important part of what you should be planning for your overall project plan, for setting up that phase-based plan. So for whatever assumptions you tend to make sure you can plan the project at a phase level. If you can't make your plan make sense phase by phase, you're never going to have it make sense at the task level. Once you've got that phase kind of plan developed, now you're in a position to start developing your tasks and activities within your work breakdown structure. Like I said, focus on how much elapsed time will something take. That's usually a reasonable estimate. If I tell someone I can get the requirements done in the next 3 days, I'm talking about the elapsed 3 days. I may not be telling them how long I think it'll actually take, maybe 12 hours of my time over those 3 days. It's really difficult to get people to accurately estimate how much of their time you're going to be able to spend on a task, particularly if they're not devoting 100% of their time to your project. So estimates based on how long something will actually take in terms of the workload tend to be very unreliable for preliminary project design. So ask them the duration. When can you have this done by? How many days is it going to take? And what are you dependent on in terms of the plan? So we want to plan tasks and activities at those levels as we go through. So here's an example. of a very simple task, an analysis phase of the life cycle is what I'm looking at here, which I already had at the phase level at 20 days, and now I'm introducing two tasks to it. One is to obtain approval for the requirements, which I'm making red. I tend to make red my approval activities so they really stand out in the plan. And I make that a milestone of 0 days because it's really just a matter of getting it. It's not work my team is going to do. So I plan it out and say analyze requirements will take the 20 days. That simply matches the phase estimate I had at 20 days. And it assumes that to do the phase, I have to finalize my work and approve the work. That's not really what I want to do. I want to expand that, but that's the first step. What I really want to do is build some iteration into my life cycle. So here's one iteration through, where instead of just finalizing and approving the work, I first conduct some work. I go do some requirements work. I document that work in terms of draft requirements, and then I review the work, usually with the customer. If it's a single loop iteration, it's usually the customer that you go through. But here's the plan you end up with. It still adds up to the 20 days. Because I have a phase level plan that says this phase is allocated 20 days, I have to plan my tasks so that I can get there. It's possible I'll find out when I'm doing the details that I'll realize it was a mistake to commit to 20 days. But for now, I'm going to try to stick to those phase estimates. So I divide up the time available for duration among the tasks I've said need to be done, and I sequentially make them dependent within the task. So I still have the finalized requirements and the approval that I had back in the beginning, but now I've split off 15 days to actually go do some work. And I tend to use a blue color in my plan for the quality assurance kinds of activities of people doing the reviews. So if I can do the phase this way rather than the way I had it in the prior slide, now not only am I getting the work approved, but I'm actually giving my customer an opportunity to comment and review what I'm doing while I'm doing it to increase the chances I'm going to have high quality as I go through. But that's the one iteration approach. If I'm going to have trouble getting the work done in this many days, I kind of have to stop there and say that's going to have to do. But if the people on the team feel I can handle it, I'd rather have a 2-cycle approach of even more tasks where I have everything about my conducting the work and documenting the work for my customer down here, but I've added an earlier cycle where I conduct work, document work, and then review the work. It's always those 3 things. But on a 2-cycle approach, I have the team do a peer review. I have my team review the work coming through. So I conduct the analysis, I draft the requirements, I have the team review it. Then I do more analysis, draft more requirements, I have the customer review it, then I finalize it, and I get approval from the customer. So I, again, reallocate my days. It still has to be 20 days, so it might be up against the limit of what can be done in 20 days. But if this seems realistic, this gives me 2 quality review cycles before the customer has to sign off on it. And that's very, very valuable as I go through. I also, because I'm getting that team review done fairly early in the process, once the team reviews it, usually most of the issues going on in the analysis are going to be pretty clean. I'm relying on the early cycles to get most of it right and the later cycles to clean it up. So if I'm relying on that, this is how I actually implement my phase overlap from the prior discussion. So I might make the next phase, in this case design, say design can start as soon as the team review is done, and I've done started my further analysis. So my downstream analysis activities can actually be happening in parallel to my early design activities, but most of my design will get done after that approval milestone. So I'm introducing a little bit of risk. I'm starting my design a little earlier while the customer is still looking at some of the requirements, but I'm relying on the fact that the team is likely to have gotten the bulk of the requirements right in the first pass of the phase. Now suppose even this, I've got a task here at 5 days, and I've got a task here at 4 days and 3 days. I don't really like tasks that are that long because they're difficult to control as I go through. So maybe I'll go with a 3 iteration cycle, where in addition to having the team review the first pass and the customer review the last pass, I'll have another pass in here where I'll have a peer review going on. People from outside my team, but for people who can understand my system, who will also review the work. So now I've got a 3 iteration cycle. Basically, conduct the work, document the work, review, conduct, document, review, conduct, document, review, finalize, get approval. So it's always the same basic structure coming through, and I'm allocating more and more discrete time to getting the work done. And so here I've left the design dependent upon the peer review. Later when we talk about squeezing the life cycle and getting things done sooner, I might consider moving that dependency back to the team review as I go through, but I'd love to hear at the peer review. Both because I want to start the phase roughly a third of the way before I'm done the first phase, but I also want to make sure it doesn't end before the phase before it. So I've got to keep my eye on this end of the design phase. If I made design dependent only on the team review, I might have a situation where I'm going to try to finish the design before my customers even approve the requirements, and I don't want that to happen. So you've got to keep those phase overlaps in mind as you go through. This is the 3 iteration approach, which is this is what you want if you can get it. Build all your phases so that the work being done is done in these 3 phases. Now this is a very generic example. It just says conduct the initial analysis. I might be able to break that out into very specific tasks in these phases, which I'm not doing here. But it says I'm going to do some work and get the team to review it and make sure I'm in good shape. Then I'm going to do some more work. I'm going to get some peer engineers to review it and make sure I'm in good shape. Then I'm going to do a little more work and have the customer review it. So the customer is really able now to focus on their needs and their perspective, knowing that I've already gone through 2 quality reviews on the requirements, and they can trust that my team is coming up with some pretty good requirements documents as we go through. So a 3 iteration approach in the phase is my preferred way to approach every project. The only way I wouldn't do this is if it forces some of these timeframes to be so short that I'm not sure my team can get those tasks done in those number of days. But if that's going to happen, you're probably already at risk with the larger time frames as things go through. So now I've got a thing where I've got my projects, my phases, my tasks, and my activities are built into a project plan. But nowhere in the plan do I know what is actually being worked on. And chances are your system's large enough, you're not just going to work on it as though it's just one solid object, because the objects you're going to work on become multipliers in your work breakdown structure. So you have to find a way to get that in. And they can be introduced at a lot of places. I could have a project dealing with an object, maybe a whole system, and a whole sub-project dealing with another object, like the facility in which it's going to be placed, in which case the objects are fairly high in my plan, or I can push them way down. So you have an option of where to put them as you go through. Most projects benefit from pushing the objects down pretty far, but let's take a look at some examples to see how that works. So here's an example plan where I've got phases and tasks, but I put my object in between. So my phase is the analysis phase, and my tasks are conducting initial market analysis, conducting the review. So I've got an iterative process here going on. So you'll see it's the same 3 tasks within each object, but the object is analyzing my marketing subsystem, analyzing my sales functional subsystem, and doing my accounting. So in this case, I've put the object fairly high up, and I said I'll simply repeat the task for each object. This works well if you're allocating a functional group to a completely different team or something of that nature, where the dependencies are within the tasks on the object and not otherwise. Another way I could have done it is to put the object at the lower level, where I've got exactly the same task in this plan as on the prior page, but now my marketing, sales, and accounting show up at the task level below the task. And the tasks, like conducting the analysis and drafting the requirements and conducting a review, the tasks now are right within the phase. So this tends to work well if the tasks are sequentially dependent on each other, and I need to know that all the work has been done across the different functional areas as I go through. So it can be done either way. Okay. Here's an example from the design phase, where I've got my objects are data structures, I/O, and interfaces, and for each one I'm doing the same set of tasks. Or I could have set up for the design to do each task for all 3 of the objects. So these plans are the same, that is organized differently. And if the dependencies look more like this, then you want to make that work. What you don't want to end up with is this kind of spaghetti plan, where you put the objects a little too high and then the task, but the work you're doing at the task level, say for data structures, is actually dependent upon the work having been done for the IOs, which is why you get a lot of dependencies between tasks in the different groups. So if you start to get this kind of spaghetti dependencies in your plan, you'll know you've probably put the objects at the wrong level. You probably should have gone with something more like this one as you go through. So watch out for those real world dependencies, and typically you'll want to push your objects in your plan down to lower levels as you see that start to happen to keep the project cleaner. Also remember you need in your project to basic project execution tasks. Don't think that everything you do on your project is systems engineering. So make sure you include a subgroup in your plan for project execution where you manage your risk logs, your issue logs, your change logs, your defect logs. Now I set these up as recurring tasks that allocate a certain amount of time every week in the plan. For building management reports and doing operations review, I might set that up to be done monthly. But don't ignore these kinds of tasks in your planning because they take a lot of resource and they actually have to happen. So don't leave them out of your plan thinking your project management activities don't belong in your plan because they will take your time as you see your way through. So now that we've built your plan, you have all your tasks, you're all worked out, you have your plan. Now, so far what I've described is a fairly iterative but mechanical translation of your engineering life cycle into a work breakdown structure for your project. It isn't really tailored to your project opportunity yet. That happens when you start to apply other project management activities to your plan, like risk mitigation. So if you're doing risk assessment and risk mitigation off to the side, you're assessing the risk to your project, you're assessing the risks to your system, you're developing mitigation plans for that. And one of the ways you know it's happening is if you're doing risk management, you should have to be adding mitigation activities to your plan. It'll be new tasks you're sticking in all over the place that are ways in your project plan you're going to make sure these risks aren't happening. So maybe you mitigate some risks by doing some extra reviews. Maybe you mitigate some risks by decomposing some of the architectural components to make them simpler. There's lots of ways to approach that as you go through. But if you're doing effective risk mitigation, you should be having to add tasks to your project plan as you see your way through. Likewise, you should be doing issue management as a project manager. Now, if issues crystallize out of your plan, so as a result of carrying out your project plan, you're going to have issues coming out of your project that you're putting into your issue management strategy, causing you to identify and assign those issues for someone to resolution. As people come up with resolution, there are usually additional resolution activities required. The issue will be closed in your issue management system as soon as you've updated the plan to include whatever activities you decided need to be done. So just like risk mitigation, issue mitigation requires putting resolution activities into your plan. So the plan is becoming now more and more unique to your project because now you've added activities for managing your risks and your issues as you go through. As you move through into the verification and validation tasks in your plan, you will also have the results of those verifications coming out into your defect tracking function. So as things go wrong, as you find mistakes, as you find errors, as you find defects, you should be tracking those as a project manager in your defect tracking tools. So you're going to diagnose those things and come up with corrective actions. So there's things that will have to be reworked and changed. So effective defect management implies that the rework activities required to correct or substitute for or redesign around some of that activity will involve, again, more tasks being added to your work breakdown structure. So the more you're doing project management, the more your project plan will look very, very unique to your project. On day one, it might have been fairly generic. It looks like the definition of your engineering life cycle. But as you're doing these other management activities, you're constantly closing out and adding tasks to your plan based on these kinds of activities. Eventually, what you're going to find is you're being asked to squeeze the plan. You were asked to do the project in 6 months. It turns out when you plan the project, it looks like it's going to take 8 months. And someone says, well, we have to try to do it in 6. So at that point, you're going to try to squeeze the plan. You have to be willing to say no if it can't be squeezed. Don't squeeze to a plan that can't be executed. But there are ways by looking at activities perhaps that are optional or activities that can be done a little faster or outsourced to someone or adding more resources or changing their dependencies. As long as what you're changing in the plan to try to implement that are the durations and dependencies, you'll get a reasonable plan out of it. Don't start trying to screw around with effort and assignments to try to squeeze your plan as you go through. So as you try to eliminate activities, you're looking for tasks in the plan that can be eliminated. The fact that you're eliminating them means you should plug them into your risk assessment and say, what's the risk of not doing these activities? And you'll get mitigations out of that. Well, if the mitigation activities you have to add to the plan take more time than the activities you've eliminated, maybe you shouldn't be eliminating those activities. Maybe you will, because maybe the constraint is you've got to have design done by Halloween. in which case getting rid of some analysis activities might help you get there, even if you've got to add a whole bunch of mitigation reviews you have to do in November as a result of having to skip those steps. So sometimes it makes sense, even if the mitigation activities are larger than the activities you're eliminating. You've got to make that call as a project manager. But every time you update a plan, you're both taking things out and you're putting things in, and you've got to be aware of that as you go through. Finally, you could increase the overlap of your phases. This part gets a little dangerous because if you're going to increase overlap, that implies you're adding resources to the plan because you need more resources to do more activities in parallel, which is what happens if you increase the overlap. So, adding resources to a project can cause some tasks to go faster, but it also increases the learning curve and complexity of your team. So it doesn't always help to add more resources. But this is basically what it looks like. So here in the central example, I've got work package 1. Here's the 3-pass process that had been put together to get that work done, with work package 2 starting right after that. So if I've got this kind of a plan put in place and I want to squeeze my schedule some, I really only have a few options. Because what I want to do is change the dependency for work package 2 to go back to one of the reviews. Rather than being dependent on the approval, I could start the next work package right after any of these reviews, and that's what this shows. So here's one that backs it up just a little bit to the prior review. Probably a low-risk way to do it is say, go ahead and start work package 2, even though we don't have approval on the first one yet. This approach here is a little more aggressive. It says, let's start work package 2 as soon as we review the update package in task 7. And here we say, let's start work package 2 as soon as we finish the initial draft review as we go through. This one up here is crazy, but I included for continuity. Let's say work package 2 isn't dependent on work package 1 anymore. I can just go ahead and release it and let both teams work in parallel. Maybe that's an option if they weren't really dependent on each other. If I only made them dependent on each other because I thought they looked that way, or I wanted one team to be able to do both in sequence, then maybe there really isn't a dependency and I can go for that. So you want to use these approaches carefully. Of these, I probably never would have a default plan worked only on approval, because I don't want my design team to sit around doing nothing during the couple of days it takes to get approval on something. So usually my base plan looks more like this one down in the corner anyway. So to squeeze the plan to move it back to one of these prior 2 are usually an option. Usually you can trim a project plan by up to 20-25% by doing this, as long as you haven't been too aggressive at squeezing it in the first place. So if you've built your plan based on a reasonable picture of how you'd like to do the project, you usually have a lot of these options available for you as you move forward, and that's what I encourage you to do. So project planning really isn't a topic in this course per se. There are courses you'll take on project management, you'll do that. But since you are trying to engineer a system and manage your own project through this course, I thought it would take some time to actually spend some time talking about project management.